Hello everyone. In this video we are going to discuss about estimation of nitrogen by Kjeldhal method. Let's try to understand this method through this diagram and reaction involved. So firstly, we'll take a known quantity of coal and heat it with concentrate H2SO4 in presence of catalyst, that is copper sulfate, in a Kjeldhal flask till it get converts into a transparent solution. In transparent solution, nitrogen get converts into ammonium sulfate. This transparent solution is cooled and transferred into a round bottom flask and digested in presence of alkali, that is NaOH, and ammonia is liberated. This ammonia is then transferred into a known volume of standard acid where this ammonia get absorbed. Now what are these reactions are? When coal is heated with H2SO4, it get converts into ammonium sulfate. This ammonium sulfate, this is a transparent solution, is treated with NaOH. This gives ammonia along with Na2SO4 and water, and this ammonia get condensed in the form of ammonium hydroxide and get absorbed in HCl and form NH4Cl and water. Now through the amount of ammonia get liberated, we have to find how much nitrogen present in coal sample. For this, the produced ammonia can be estimated by the amount of hydrochloric acid used in the reaction, and it can be done by the estimating the amount of hydrochloric acid left after the absorption of ammonia by titrating with standard alkali solution. This is referred as back titration. And for determining the amount of acid absorbed by ammonia, we have to carry out blank titration. Means what? When an acid there is no ammonia get absorbed, the same quantity of acid we have to titrate with alkali. That is called blank titration. Now we have two volume with the titration with the NaOH. One is the blank titration volume and one is the back titration amount or the volume. So now by the difference between initial amount of sulfuric acid taken and amount that left after absorption of ammonia, we can find, let us, we have W gram of coal taken in Kjeldhal flask and volume of acid consumed by sample titration, that is back titration, where ammonia get absorbed in that acid. The titration endpoint comes suppose at V1 ml, and volume of acid consumed by blank titration where is no ammonia get absorbed, the same quantity of acid we have titrated with alkali, it is suppose V2 ml. Volume of acid consumed by ammonia will be now with the, this is blank minus back titration value, that is V2 minus V1 and we will get it here, volume of acid consumed by ammonia. And by when we are getting the volume of ammonia, that is equivalent to your the 1 equivalent of HCl. So here 1 equivalent of HCl equivalent to the 1 mole of ammonia, and that is equivalent to the 1 equivalent of nitrogen. And 1 equivalent of HCl is equivalent to the 1 equivalent of nitrogen, and 1 equivalent of HCl, it will be, can be written as 1000 ml of 1 normal hydrochloric acid equal to 14 gram of nitrogen. And we have not 1000 ml of HCl, we have in that titration value amount of ammonia get absorbed by the acid is V2 minus V1 ml. So V2 minus V1 ml of, suppose we have taken here the normality of acid is Na. So V2 minus V1 ml of Na normality of acid equivalent to V2 minus V1 into Na, that is the normality of acid, into 14 by 1000. So W gram of coal contains V2 minus V1 into normality of acid, that is Na, into 14 by 1000. So for the 100 gram of coal contains, because we have to find out the percentage. So for the 100 gram coal contains V2 minus V1, that is volume of acid consumed by ammonia, into normality of acid into 14 by 1000 into 100 by W. This W is the weight of coal. So percentage nitrogen comes as V2 minus V1 into Na into 1.4 by W, or we can write this formula as percentage nitrogen equals to V2 minus V1 into normality of acid into 1.4 upon weight of coal. So this is about how to determine the percentage of nitrogen in this ultimate analysis by Kjeldhal method. So thank you and happy learning.